this definite integral is going to find the area under the curve from 1 to e on this function here. So I'm going to anti-differentiate and use the displacement on the antiderivative to calculate the area. So to anti-differentiate this, I'm going to use substitution. So I'm going to let u be log 2x. So my du then becomes 1 over 2x times 2. I have to remember to use chain rule. And then that lets me get rid of that extra 2. So I just have 1 over x dx. Okay, so there's the derivative takes care of the outside part of this. So now I can just put this in. Now, whenever I use a u, I have to make sure that I state my bounds are in terms of x's and not u's. Okay, so x equals 1 to x equals e, because my expression then is now in terms of u. So I have u times du. Okay, so if I left it as 1 and e, that would mean that my bounds are in terms of u equals 1 and u equals e, which is not true. Okay, so I'm going to now anti-differentiate this. So I'm going to end up with u squared over 2, and I'm going to integrate that for my bounds. Again, I have to make sure I keep clear that my bounds are in terms of x. And then once I substitute back for my u, so my u is 2x, log 2x. That was my u. Now I can change my bounds back to x. So I can just get rid of that x equals 1 and x equals e. So then the displacement on this antiderivative function, when I plug it in, so I end up with log 2e squared minus log 2 squared all over 2 will give me my solution here. Now I can simplify. We can probably just plug this into our calculators, but it does simplify algebraically. But for our purposes, we're probably okay just using the decimal value. So log 2e squared minus log 2 squared, and divide that by 2, we end up with a decimal value of 1.193. So I'm just going to round that to 19. So that represents the area under the curve, or the displacement on the antiderivative.